Okay, welcome back. This is my fourth example. In this example, we are going to deal with a square root. If you notice, the function is a square root, but inside of it, you have a 4x plus 1. Again, this is a composite function, which is kind of your hint that you're going to be using u substitution. So the first thing I need to decide is, am I going to let the square root be u, or am I going to let 4x plus 1 be u? And of course, 4x plus 1 is a more complicated situation. And anyway, if I have to do the square root, its derivative wouldn't appear here anywhere. So that's my hint that I'm going to go ahead and go with 4x plus 1. I'm going to take the differential of both sides. And remember, when I say differential, I really mean the derivative of u, which is 1, and then you have to multiply by du. We did this a while back. The derivative of 4x plus 1 is 4, and we're going to multiply that by dx. Now let's go ahead and start our substitution on this side. We are going to take the integral of the square root, and now the 4x plus 1 is going to get replaced completely by u, and then it's times dx. Remember that you want to get rid of this dx because you have to have the same variables. I mean, you can't have different variables when you're taking an integral. And I don't have a dx here, but I do have a 4dx. And I can easily get rid of the 4 by dividing. So I get 1/4 du, and that's going to equal dx. So I'm going to go ahead and take dx here, and it's going to get replaced by 1/4 du because that's what dx is equal to. So let's rewrite this integral. We have the integral of the square root of u times 1/4 times du. And as in previous examples, I really like to clean up this integral by taking the 1/4 out. I'm going to put the 1/4 out here. And I'm also going to change this from square root to u to the 1/2 because I'm about to take the antiderivative. There's my du. And now I'm going to work on those boundaries. Remember, you have to plug those into the u equation, so I'm going to put in a 0, and that's going to give me 4 times 0 plus 1, which is 1. So that's my lower boundary. My upper boundary, I'm going to go ahead and put in a 2. Okay, and so you put in a 2, and you get 4 times 2 plus 1, which of course is 9. And so that's the top boundary. So now I just need to evaluate this using fundamental theorem of calculus. Let me see if I have a little more room over here. I'm going to put my 1/4, that just sits there, and my placeholder from 1 to 9. Now, because of this being written as a power, I'm going to go ahead and add 1. That's the same as adding 2 over 2. So that's going to result in u to the 3/2. And then I'm going to multiply by 2/3. The reciprocal. Now, just to make it even easier, I can go ahead and take this 2/3 and just kind of pull it outside because it is a coefficient. And so that gives me, well, 2 reduces with 4, so really it gives me 1/6. And I'm going to go ahead and put in the 9. So I get 9 to the 3/2 minus 1 to the 3/2. Well, I'm going to try to simplify this without a calculator. 1 to the 3/2, that's just going to become 1, no matter what. 1 to the whatever power is 1. This one, if you remember, this is the same. The bottom is your root. So it's the square root of 9, and then the top is your exponent cubed. So the square root of 9 is 3, and then when you cube that gives you 27. Okay, so we're going to have 27 minus 1. But don't forget, you got a 1/6 here. So we're going to multiply that by 27 minus 1 is 26. And so you can reduce this obviously by 2. So you end up with 13 over 3 as your final answer. Something I want to mention that I guess I haven't said in the previous videos is that all of these can be checked with a calculator. You can do Math 9, and it should give you the decimal version, so you can always check your work even if you don't have the key. So hopefully that made sense. Remember, as always, you can send me emails and let me know if you have questions. See you soon.